Hi everyone, myself Dinesh, Assistant Professor from the Department of Mechanical Engineering, SNS College of Technology. Okay, in today's video, we are going to see the solar energy storage and economic analysis. Okay, so in our video series, we have been seeing about solar energy utilization. So in that, the fifth unit is what we call it a solar energy storage. Okay, so first let's see the uh, mind mapping of what we are going to study. So the first, the solar energy storage and the economic analysis, we can divide it into two main categories. Okay, the first one is solar energy storage. Okay, the solar energy storage is a place where the energy of solar is stored. Okay, so it can be done by multiple purpose, like for example, let's say hybrid system. There are mechanical storage and there are batteries, and also there are thermal storage. Okay, so the thermal storage can also be broadly classified into latent and specific heat. Okay, so these are all the topics which are covered in the solar energy storage. Okay, now when we come to the economical analysis, there are certain terms which we have to understand in order to analyze the economic of solar is payback period and LCOE, okay, which we call it as a levelized cost of energy, and then NPV, which we call it as net present value, and ROI, okay, the return of investment. Okay, so the main purpose, okay, why we have to study this about the solar storage is, we know that solar energy is available at a large amount. For example, in a day, we get an effective 7 to 8 hours of solar energy. Okay, and we can collect it, but we need a proper storage so that we can use it at the night time. Okay, so that's why it's very much important. So solar energy is equal to intermittent. Okay, actually we can be used it can be used in homes, industries, and all the communities. Okay, nowadays most of the countries have been concentrating on solar energy. Okay, because the main reason for is the availability. The second one is it has no very less pollution. Okay, so need, when it comes to the need, it's reliable and 24/7 power. Okay, and low cost storage. Okay, comparing to other storage, the cost of the storage is very low, and the lifespan is very high. Okay, so India target 500 gigawatt renewable energy by 2023. Okay, so it's a report from MNRE in 2025 update. Okay, so so let's see a quick assessment. Which is the main challenge of solar energy? Okay, so the main challenge of solar energy is, okay, high CO2 emission, intermediate of sun, lack of government policy, and easy storage. Okay, so the answer is B. Okay, so the problem statement, okay, the problem statement for this topic is solar energy availability is not equal to demand time. Okay, we have to understand that very well. Okay, so demand time is not equal to solar energy availability. Okay, so we need something which can store the power. Okay, so the key aspect is storage efficiency, economic viability, and scalability. Okay, the statement, how might we design storage system that are efficient and affordable? Okay, so this is a statement which we have to concentrate while designing a solar storage. How might we design storage system that are efficient and affordable? Okay, the system should be affordable. At the same time, it has to be a very much efficient. Okay, so ideal. Okay, so the storage option, when it comes to storage option, we have thermal storage, battery storage, mechanical storage, and hybrid and economical tools. Okay, so these are all the options. And then uh, prototype. Okay, the prototype, we have small scale, medium scale, large scale, and economical prototypes like ROI models or break even charts. Okay, so these are all the prototypes which we have been using right now. Um, and a small assessment: what's the main challenge of solar energy? The answer is intermittency of sun, we know that. So how to test the storage? Okay, so first we have to test based on the performance or efficiency, charge or discharge rate, and then the economic, which is ROI, payback cost, uh, and then the feedback, users affordability and reliability. Okay, so these are all the tests which you have to conduct after designing a solar storage system. Okay, so these are all the reference which we have been used in this PPT, which are MNR India, IEA, CATL, and Spain Morocco CSP project 2025. Okay, the final engagement. If a village had 100 homes powered only by solar, which storage would you choose? Why? Okay, so this is a question which you can answer. Okay, a village has 100 homes powered by solar. So, what type of solar storage you are going to use? Okay, and why you are considering that storage? Okay, if you know the answer, you can comment below. Thank you.